In this day and age, there are smart versions of pretty much every home device. Since the main object of this project is design a smart MCCB for house power distribution circuit, let me introduce the topic of this project, and that is smart MCCB using big microcontroller. As you can see, this project is done by Group G28. In the market, there are circuit breakers available that provide protection against under and over voltage. But once circuit breaker is detected a problem in the main AC power supply, it is turned off main AC power supply permanently until someone manually turn on the switch again in the circuit breaker. The disadvantage of the circuit breaker is that you have to control it manually. The main objective of this project is to add automation function to turn on and turn off the MCCB in case of overvoltage and undervoltage of the main power supply. This smart MCCB is designed by main 5 components. Voltage sensor and microcontroller are the main parts of this MCCB. PIC16F877 chip is used as the microcontroller, and it makes this device smart and intelligent. A different amplifier is used as the voltage sensor. Rest of the components are LCD display that shows present time voltage and if there is fault occur or not, power supply and high speed relay system.
So this is the Protein simulation of our Smart MCCB project. We have used 16F877A microcontroller for this project. This is the voltage sensor part with the peak detector. This is power supply, crystal oscillator and LCD display. This part has the main circuit and the relay which is working as the MCCB. I have chosen 220 volt to 240 volt as the safe voltage region. Let's give 230 volt to the sensor. As you can see, LCD display shows 230 voltage and no fault. The relay is not turned on and the current runs perfectly through the main circuit. As you can see, L1 is on. So let's use 250 as the over voltage. As you can see, the relay is turned on and L1 is off, so there is no current through the main circuit. Because the LCD display shows voltage 250 and a fault, let's give 236 volt which is in the safe region. The relay is turned off and L1 is on, current is flowing. Let's consider a undervolt situation and give 212 volt to the sensor. As you can see, relay turned on, L1 is off and there is no current through the main circuit.
Let me briefly explain the programming part. First part of the code, all the general purpose registers, banks and constant are defined. Under the main function, initially all the output and input ports are initialized. In here, port B and port D are set as output port and port A 0-bit line set as analog input line. Then delay 5 function is to wait 5 milliseconds. Init LCD function is initialize the 16 by 2 LCD display according to our requirement. Init A to D function is initialize the analog to digital converter in the microcontroller. Under the read voltage subroutine, read A to D function read the input analog value and convert to digital value. Then the stored digital value is compared with the predefined voltage value. This is done in the compared function. The high voltage reference and low voltage reference already defined in the program. If the current voltage is not in between these references, the port B 7 bit is set to high. If not, it is set to low. The multiply by 100 and divide by 51 are convert the digital value to actual peak voltage of the AC signal. Bin to AC is convert the binary value to ASCII value. Purpose of this conversion is to display the current voltage in the display. Showline function is shows the current voltage on the display. In here we check the current state of the port B pin. If it is high, the fault message shown in the display, otherwise it shows no fault in the display. Then go back to the read voltage function to repeat the procedure. Rest of the code is all the subroutine that are used in the main function.